Imagine a world with no video games, no smartphones, no internet. It's hard to picture, isn't it? But not so long ago, that was just how the world worked. Before computers, everything was done by hand. If you wanted to send a message to a friend far away, you had to write a letter. You would put it in an envelope, add a stamp, and wait for days or even weeks for it to arrive. There was no instant messaging, no email, and no video calls to see your family across the country. It was a much, much slower world. Think about doing your homework. If your teacher gave you a math problem, you would use your brain, a pencil, and a piece of paper. For very big numbers, you might use a special tool called a slide rule or an abacus, which is kind of like a calculator with beads. Businesses had huge rooms filled with people called computers. These people's entire job was to do math all day long. They calculated everything from bank records to the paths of stars in the sky. It was hard work, and it was really easy to make a small mistake that could cause big problems. Let's consider how information was stored. Today we have libraries of music and movies that fit in our pockets. But back then, information was physical. Books were the main way to store knowledge, and libraries were giant buildings filled with thousands of them. To find one piece of information, you had to look through card catalogs and then search the shelves. Music was on big vinyl records. Pictures were developed in darkrooms and kept in photo albums. Everything took up space, and finding what you needed was a major task that required patience and a lot of searching. Life was simply different. Maps were on paper, not on a screen that could tell you where to turn. To learn about a new topic, you couldn't just Google it. You had to go to the library and hope they had a book about it. People were incredibly smart and did amazing things without digital help, but they knew there had to be a better, faster, and more accurate way to handle all the numbers and information that were becoming more and more important for science and society. This need, this big, important problem, is what sparked the idea for the first computer. The dream of a thinking machine. So, why did people need a machine that could think? The biggest reason was to avoid mistakes. Human beings are amazing, but we get tired. We get distracted. When you add a long list of numbers, you might accidentally write a 7 instead of a 1. For a small grocery bill, that's not a big deal. But what if you were building a bridge? Or calculating the path of a ship at sea? A tiny math error could lead to a huge disaster. People dreamed of a machine that could perform these calculations perfectly every single time, without ever getting bored or making a simple mistake. The world was also getting much more complicated. During the 1800s, there was an explosion of science, trade, and engineering. Scientists were studying the planets, and they needed to calculate complex orbits. Governments needed to count all their people, a process called a census. Banks needed to track massive amounts of money. All these tasks required millions and millions of calculations. Doing this by hand was slow and expensive. A machine that could do this work automatically would save a huge amount of time and money, allowing people to focus on bigger ideas and discoveries. This need wasn't just about doing old tasks faster. It was about doing things that were almost impossible for humans to do alone. Imagine trying to create a table of logarithms, which are special numbers that help with difficult multiplication. A team of people could spend years creating one of these tables, and it would still likely have errors. An automatic machine could do it in a fraction of the time and with perfect accuracy. This would open up new possibilities in engineering, astronomy, and navigation, making everything safer and more reliable. The dream was not just for a calculator, but for a powerful new tool for progress. So, the desire for a computer came from a very practical place. It was born from the need for accuracy, speed, and the power to tackle problems that were too big for the human brain to handle on its own. It wasn't about playing games or watching videos. It was about advancing human knowledge and building a better, more efficient world. The inventors who took on this challenge were not just building a machine, they were trying to build a new future, one where tedious work could be done by gears and levers, freeing up human minds to dream even bigger. Babbage and Lovelace. The story of the first computer really begins with a brilliant English mathematician named Charles Babbage. He lived in the 1800s, a time of steam engines and new inventions. Babbage was frustrated by the errors he constantly found in math tables calculated by humans. He famously said, "I wish to God these calculations had been executed by steam." He dreamed of a machine that could calculate and print tables automatically. His first big idea was the difference engine, a massive mechanical calculator made of thousands of gears and rods, all powered by a hand crank. Babbage was a man of big ideas. While he was still working on the difference engine, he had an even grander vision, the analytical engine. This wasn't just a calculator, it was a general-purpose computer. It was designed to be programmable, meaning it could be told what to do. It had a mill to do the calculations, kind of like a modern CPU, and a store to hold numbers, like memory. It could even make decisions based on the results of its calculations. It was a revolutionary concept, more than 100 years ahead of its time. Sadly, the technology of the day wasn't advanced enough to build it, and Babbage never saw his creation come to life. But Babbage didn't work alone. He collaborated with a remarkable woman named Ada Lovelace. She was the daughter of the famous poet Lord Byron, but her passion was mathematics. When she learned about Babbage's analytical engine, she was fascinated. She understood its potential better than anyone, including Babbage himself. She translated an article about the engine and added her own notes. These notes were longer than the original article and contained some incredible ideas. She realized the machine could do more than just crunch numbers. In her notes, Ada Lovelace wrote out a step-by-step sequence of operations for the analytical engine to perform. This sequence is now recognized as the world's first computer program. Because of this, Ada is often called the first computer programmer. She imagined that the engine could be used to create music or art if you could translate them into numbers and instructions. She saw that it wasn't just a machine for math, but a machine for manipulating symbols of any kind. This was a truly visionary idea, connecting the world of logic and machines to the world of creativity. The legacy. So how was this early computer supposed to work? Babbage's analytical engine was entirely mechanical. Imagine a giant clock, but instead of telling time, it solved math problems. The machine would be programmed using punch cards, which were stiff cards with holes punched in them. The pattern of the holes would tell the machine what to do, like which numbers to use and whether to add, subtract, multiply, or divide them. A rod would pass through the holes to turn specific gears, setting the machine in motion to perform the correct calculation. It was a brilliant system of physical instructions. The impact of these early ideas was enormous, even though the analytical engine was never built in Babbage and Lovelace's lifetime. Their concepts laid the foundation for everything that followed. They established the basic principles of computing. A machine needs an input, the punch cards, a memory to store information, the store, a processor to perform tasks, the mill, and an output to give the results, like a printer. Every single computer today, from your laptop to your phone, follows this same fundamental model. They just do it with electricity and tiny silicon chips instead of giant metal gears. The world we live in today is a direct result of their vision. Think about it. The weather forecast you check in the morning is created by supercomputers solving complex equations. The movies you watch with amazing special effects are made with powerful graphics computers. The medical discoveries that save lives are often found by analyzing huge amounts of data with computers. Every time you search for something online, send a text message, or play a game, you are using the direct descendants of Babbage's and Lovelace's incredible dream. Their story teaches us that even ideas that seem impossible can change the world. Babbage and Lovelace were pioneers who saw a future that no one else could. They imagined a partnership between humans and machines that would unlock new potentials. While their machine of gears and steam never came to be, their ideas waited patiently for a century until technology caught up. Their work is a powerful reminder that the greatest inventions start with a simple question. Is there a better way to do this? And as we can see all around us, the answer was a resounding yes.